In number 15, it says that which triangle represents the following transformation of triangle ABC? And so our transformation is negative 9x, and then the y is negative 1. So we're going to go left 9, down 1. So I'm going to pick a point. I'm just going to pick B. I have to go 9 to the left, and then down 1. So I land at triangle 3. Okay, in number 16, we see that the angle, or if I were to draw from here to here, to F, I would draw the exact same line back to F. So if it was rotated all the way around, that would be 360 degrees. So that would be A. Okay. In number 17, we need to find all the points, and then we have to dilate it by 4. So for A, we would have negative 2, 5. But if I multiply both by 4, because that's what it tells me to do right here with the 4, I would have negative 4, 20. Okay. Then letter B, so point B would be 3, negative 3. And if I multiplied those by 4, I would have 12, negative 12. Then for C, I have negative 4, negative 1. Okay, so if I multiply that by 4, we get negative 16 and negative 4. In number 18, looks like our picture is missing, so we cannot do that one. In number 19, we have angle side. So angle, side. And we can see it matches up. Angle, angle. Actually, it doesn't match up. You see how this side is next to the double, and this one is next to the single? They don't match up. So this is D. Not enough information. In number 20, which additional piece of information would prove triangles ABC and triangle JKL or JLK are side angle side? So we have the two sides. If the angle has to be in the middle of the two sides, it has to be placed here. So I would need to know that C and K are congruent. So it looks like B. And in 21, to get X, the exterior angle of a triangle is equal to the remote, which is like the opposite, angles in the triangle. So X plus 90 equals 123. If I subtract 90 from both sides, we get 33. So that X is 33 degrees. A. Okay. In number 22, we are told that angle A is congruent to angle B. And so if we kind of rotate this around, we see that this looks like an isosceles triangle where the angles are congruent, which means then the legs or the sides there have to be congruent. So X has to be 7, so B. Okay. For 23 through 25, we have our proof. Alright, so it says B is the midpoint of CA. Okay, so right here, B is the midpoint of CA. That's given to us. So if we know that, we know that CB and AB are congruent to each other here by definition of midpoint. So looking down here, CB and AB, that has to be number 23. Okay, then we're given from here that CD is congruent to AD. That's given. Then it says that BD is congruent to itself, BD. Well, if something is congruent to itself, that's by the reflexive property of congruence. So that would be number 24. And then if you look, we discussed that these are congruent because B is the midpoint. We know that BD is congruent to itself, and we already know this is congruent to each other. Well, you've just proven this by side, side. You have 3 sides. So, to prove the two triangles are congruent, That would be my side, side, side. Okay, and then 26, A and B, determine if the line segment lengths create a triangle. So I find the two smallest sides, I add them, and they have to be greater than 10, the third side. So 8 plus 3 is 11. That is greater than 10. So yes, that would create a triangle. In 26B, we have 4 and 9 as our smallest numbers. Well, 4 plus 9 is 13. So that is not greater than 18. So that means it's no. It would not create a triangle.